So yeah, this is a nice. This is off of NASA's website, I think. It's interesting that they use Amazon's web service for it, but anyway, as far as there's an inverse, there's a reciprocal relationship between frequency and wavelength, right? So most of the time they measure it in wavelength, like the distance between the waves, right? So if I wanted to mark, you know, the position at the top of this wave between the top of that wave, I suppose I would get, well, somewhere around 10 to the 12. Well, that's actually the frequency. And then you look it down at the actual wavelength, and I would get like a millimeter, right? At this point, it's a millimeter, and then it goes on, right? And so that wave's a little bit smaller, that wave's a little bit bigger, right? So the longer the wavelength, the well, how should I say this? I'll do another share here. I think I have to stop sharing here and share a whiteboard. Da, da, da. So usually you use wavelength as the Greek letter lambda, right? And the frequency is just 1 over the wavelength, right? Is that correct? If I can remember correctly. So the frequency is a measure of, is measured in hertz, which is just a cycle per second, right? So the smaller lambda is, the larger or the higher the frequency. Does that sort of make sense? So the bigger the denominator gets in this fraction, right? The smaller the f will get, the frequency. Right? So the frequency is just how often the wave repeats, and the lambda is just the distance between waves. So as that gets shorter, f gets higher, right? So see how it's kind of an inverse relationship, or it's actually a reciprocal kind of relationship? Okay. Hopefully, does that make sense? Oh, fine. I'll just. Okay. All right. All right. Good input. Good input. Anyway, so this is what we're looking at, okay? And that was the equation behind it. So if I look at the distance between waves as it gets, it looks like it's getting bigger here, right? This is out to 100 meters, right? And the hertz, or the frequency, is getting smaller, right? And so the frequency is getting larger here, and so is and the wavelength, or lambda, is getting bigger going to the left. And so I don't know if that hopefully gets you to conceptualize wavelengths and things like that. Not that it's all that important, I guess, to remember, but I think it is. Anyhow, certain wavelengths and certain frequencies. So when you talk about wavelength or frequency, you can interchange those. You can't interchange the numbers, but you can talk about a wavelength or a frequency of electromagnetic energy, and talk about it as being relevant for certain applications, right? Such as visible light. So we see, yeah, right on the right of this graph here, we have visible light in a very narrow band spectrum, right, of wavelength or frequency, right? We can say it either way. So going from left to right, if you look at that right side, you get the infrared and near infrared, and then you get red, right? And then what? Red, orange, yellow, green, blue, indigo, and violet, the Roy G. Biv, right? And you notice like children's toys, they're in that color scheme too, like the the little donuts you put on the little, you stack them and it gets fun. That's in the same red, orange, yellow, green, blue. Yeah, no. Anyway, so and then past that you get like ultraviolet, right? And then you would get smaller wavelengths and higher frequencies past the blues and stuff, right? So red has a longer wavelength and a higher, lower frequency. Blue, shorter wavelength, higher frequency. Okay, good enough. So who cares, right? Well,
cool because for my painting, those things apply.
Yeah.
The values and what your eye is drawn to first.
So your eye is a sensor in that respect, right? And the paint, so there's two kinds of color schemes that we think of, additive and subtractive, right? And when you look at a screen, that's additive, right? Because when you add colors, it gets brighter because it's energy. You're actually plugging it into the energy source to generate this color, whereas paint, ink, canvas, printers and stuff like that, color printers, they use reflective colors where the light is reflected off of those things, and certain colors or certain wavelengths are absorbed or diffused, while some are reflected more how do you say, more accurately, where it doesn't diffuse them, it just reflects them stronger. Does that make sense? So blue, right? The fibers in that reflect blue without dispersing them, whereas reds and greens and yellows would diffract and you don't see those colors, right? Or absorb them even, right? So they don't reflect them. So, okay. The Earth does the same thing, right? The sun is shining on the Earth, half of it at least at a time, and it's reflecting in certain materials like vegetation reflect certain wavelengths better than others. As it turns out, vegetation reflects infrared and near infrared well, and not the others, right? So you can get good vegetation mapping by sending up a satellite and put a sensor on there that is sensitive to infrared or near infrared. And likewise, you can set up satellites for water or smoke or cloud cover and things like that. And so you have all kinds of, and so if you go to, as long as we're here, I have in Canvas a page, a link to a list of good satellite resource data. So let's see. That was last time. So I haven't published this assignment yet, but I will once we, I don't know, talk about it, and then, where is it? So we'll have some sort of satellite imagery assignment here, and it's not published, like I said, but I put a table in here that can help us. So if you want to, ultimately what I want you guys to do is pick a spectrum, right? Pick a wavelength that's interesting to you, like cloud cover or pollution, vegetation. Well, and that's pretty much what you get. For elevation also, because that's just, you can get elevation data, but that isn't as interesting probably just because it doesn't change a lot, I guess, but this stuff does, right? Vegetation changes, coastlines change. Like if I wanted to do the coastline before Katrina and the coastline after Katrina or something like that, or just the coastline over the past 100 years around New Orleans and see how it's receded. Supposedly it's receded quite a bit, and that's why the hurricanes are getting worse and worse, because there's not enough land to slow it down and things like that, or to zap its energy and stuff. But anyway, you could do something like that with satellite imagery because, you know, they've been collecting data, maybe not for 100 years, but satellites have been up for a while, at least today, you know, years and years. So, okay, so there's a couple links for downloadable data. Here's a list of free satellite imagery you can get. So I click on that. Yeah, so as far as like, I would pick a appropriate wavelength, like there's aerosols or whatever. So if I wanted to look at aerosols or maybe fire mapping, things like that, you could look for different cloud particle stuff. Ash, this would be a good one. 3.9, and that's in micrometers, right? 1/1000th of a meter as far as wavelength goes. So that's pretty good. And it tells you, I think, so if I was interested in number 7 here, and here's a link, there's a reference where I got that. Anyway, if I was interested in the 3.9 micrometer wavelength, and because I wanted to look at fire or something like that, then I could use, this is all GOES satellite, which is what the Earth satellite, what is the observation Earth satellite, the geo-observational Earth satellite or something like that. But if you look at GOES satellite, if I think I have it here. Well, is it in here? There's the Earth Explorer. Well, that might be the GOES one. But it has some explanatory uses for the satellite, because each satellite has a specific sensor array, right? Not just one sensor, but you can put more, right? So you can get what's called a multispectral data from the satellite, and we can map that as well. Arcgis Pro can handle there's actually a couple things you can do. It can handle both, but also data is, in this respect, because there's a time element, it has another dimension to it, right? So it has the X and Y location, right? And it also has the data, which you might call a third dimension, and it also has time, which is like a fourth dimension, right? So you're getting like this really robust set of data with this stuff, because there's a time element. And so there's some tools that I want to show you. I'm going to share a video with you once I pull it up here that I want you to see, and how ArcGIS can handle like this kind of data. Finding it is another thing, but these links should help us find that. So yeah, there's like a list of 15 different places where you can get this good data. I think the first one is probably the nicest one. So here's some coastline data. So if I was interested in that Katrina data or whatever, if I wanted to take a look at how much it changed after Katrina or something like that, might be interesting. Maybe I would use this one. So anyway, let's go to let's take a look at the Earth Explorer. Is a lot like the national map that we've used before. Remember how to use that? Remember how we did that? So this one's a little different because you can put a time constraint in there to look for data within a certain time span, right? So let's actually look at that. I'm gonna pull that up. All right. I'm gonna log in. Okay, let's say I don't know. Let's try that Katrina thing, right? So I'll just zoom in around here, and a lot like I said, mentioned before, we can use the map, right, as our search reference. Now, satellite images are kind of big, right, and they're not very high resolution, right, but they cover the Earth, for crying out loud. So you would not expect them to be as finely resolution as satellite, as aerial imagery or as drone data or whatever, right? So, okay, so I pick the area that I want to search for data sets, and then I go to the data sets. It really just has some tabs across the top, but you can just go and, like a wizard, go step by step. It'll step you through it. And then we look for the different satellite programs that were sent up. Yeah, and
Where's the button for classified data?
yeah, declassified. Yeah, that's if you want to click on the information here. Yeah, it's data that's been declassified, right? I don't know what's in it, but yeah, the first generation of U.S. photo intelligence satellites. That's interesting for sure. I wonder what. It looks like it's just imagery for different time periods, huh? So that's cool.
Yeah.
Mostly over Russia, I would expect. Just kidding. It could be anywhere, right? Yeah. All right. Okay. So, I was going to come back here, and I was interested in, let's just say, Landsat, right? It's been circling the planet for quite a while. Yeah, well, it doesn't really explain what Landsat, what kind of data it collects, but there is Landsat here. Where is it? Landsat. Yeah, there's legacy mission data, which is more specific stuff, I guess, but so maybe not as useful. Collection 1, collection 2. Those could be different time periods. I don't really know. You'd have to read about them. So that's the key here. There's little information snippets there. So if you're looking for a specific thing, that's what you would do if you didn't already know, right? of this. So dynamic surface water extent. So let's see. Let's just pretend we wanted this. So I click on the thing, make sure it's what I want. Surface water. Nice. So this would be like maybe we were interested in, well, that might do the coastline okay, but that's not really surface water. I mean, it is the surface of the water, but I think they're talking about land, like lakes and rivers and stuff. But anyway, let's just say we want that. Although I would read through that and look at, yeah, so the Landsat 8 is from April 2013. So yeah, maybe, when was Katrina anyway? I remember.
Before COVID, right?
Say what? 2010? What?
I don't know, but I can find out real fast.
Yeah, we can look at
It was before COVID, right?
Yeah.
Let me see. Yes.
2005. Wow.
Okay. Yeah. Yeah. Okay.
You know, the worst part about it too was all the killing that went on in the stadium.
Okay, so
Just like
real quick, right?
So it does look like the first 3
Dark Ages.
could be potential candidates for getting the data out of the collection. Landsat 5, 7. Yeah. So let's try Landsat 7. Sorry, you had a question though.
Yeah, I can't get to that.
Oh, yeah. If you want to go there, sorry. Yeah. I didn't realize you were following along. Yeah, if you go to Earth Explorer, one word,
Okay.
.usgs.gov.
Yeah, got that.
That should pull you up there, and then you can zoom around wherever you want. You don't have to do what I'm doing, of course, but yeah. Okay, so I'm going to pick, if I can find it, Landsat. Let's see what this other stuff. Yeah, So maybe Landsat 7. And so I check one of these and look for, I don't know, any additional criteria. Oh, wow, you could really get specific about that, but then that's super cool. But under search criteria, I also want to specify a date, right? Search from. If you don't, you're going to get a lot of data probably, right? I mean, for all of time, I guess, if you don't specify something.
Let's see,
So yeah.
it was Tuesday, August 23rd.
Okay.
It ended on Wednesday, August 31st,
Oh yeah.
2005.
So I'm going to look through from July 20th through and then past it, right? So so maybe just the end of the year of 2005, right?
Oh, you can't say current or present? You have to give it a date.
No,
Well, I kind of don't want to, just because you give it too much, you get too much data.
Oh, yeah.
That might be too much also. Maybe just right afterwards, huh? Come to think of it.
29.
so the last day was Wednesday, so I would say October 1st or November. It took them a while to even get all the information from there. But you're all right, December.
Well, the satellites, they don't care, right? How hard it is to get there.
Yeah.
So they're just going to cover it. So maybe just a week maybe after the, yeah. So when was it again?
It ended August 31st.
Okay, so I'll do September. I'll narrow it down quite a bit here. So September 1st to August, so August 30th to September. So those 3 days, right?
Well, actually, it started August 23rd.
Oh, really?
Yes.
Wow, that was a long storm. Okay, okay. So I'll go 22nd of August.
And then it ended on the 31st.
Okay. So a day before and a day after. Nice. Thanks for looking that up.
How did you make your square?
Oh,
How did you highlight it?
so what I did, so that's a great question. I kind of just, gleaned right over it. But so I clicked on Use Map. So I zoomed in on the area I was considering, and then I clicked on Use Map, and it put that rectangle in there. And then you can edit it, right? So I'm mostly concerned with the delta, but going any smaller is not going to help too much, I don't think. So you can just make,
Where's the use?
In the middle
Yeah.
section.
if you're on the search criteria,
Yeah.
you can scroll down and there's a whole area for,
Latitude and longitude.
See where it says use map down there below the coordinates?
Well, that was important.
Yeah, right below the map, right below the arrow.
No, oh, use map. Yeah. Got it.
Yeah.
I got it. Well,
But how did you shrink yours down?
you can grab the pins and just move them around.
oh,
Didn't give me any.
You click Use Map.
Oh, there, it's okay.
Oh, there you go.
Oh.
Yep. Right, it fills your map screen with that red, and so you zoom out a little bit, and the pins will be on the corners.
Right.
Good.
Well, in Houston, got hit hard with that.
how do you just grab the head?
No,
The pins.
Zoom out. Zoom out.
Oh, there's. Oh, zoom out.
Nice.
Oh,
Are you
Then
gonna
then
move
there's
it?
some stuff to
You
go
gotta move it from Iowa down to Louisiana.
Right.
So,
Just right click it, delete it.
You can reset it too. You can clear the coordinates over there if you
Yeah,
kind
yeah,
of,
yeah. Okay. I didn't do- okay.
or you can add coordinates if 4 places is not good enough for you.
And then you-
I like how it shows the underwater shell borders. You see what I mean?
Yeah.
It's even-
I believe that's
Roll out.
bathymetric data, like sonar driven, and you can kind of tell because it's real pixelated,
Yeah.
but that's, yeah, that's just interpolated sonar data,
Go
I
back
think.
in a little bit now. There you go.
I just think that's cool because the plates are what shifts.
Mentioned was in New Orleans, like you said, it's low. And not only that, but the Army Corps of Engineers, right? They had built the levee system for the Mississippi to keep, well, everybody wanted to build on the banks of the Mississippi or whatever, right? And so you had to build this levee system to keep it from flooding. But what that does is it speeds up the river, right? It doesn't allow the river to naturally expand and contract as it's supposed to, I guess, right? I mean, you can form your own opinion about that, I guess, but yeah, and so what it did is sped it up and it washes out the delta, right? And so you have less land to slow down these hurricanes.
So all of New Orleans is below sea level, like 20 foot, 15
Right,
foot.
that's so scary.
And the only thing that keeps it going is all the pumps in the city. So you lose electricity, no more pumps.
So what would it do? It would just
Flood, yeah.
It's 15 foot below sea level.
Why?
That's why I say, why would they want to build something there and then keep building it there when it floods?
Yeah.
Unless you put everything on 20-foot stilts.
Yeah.
But they're just sucking up the little space.
Mm.
Because nobody learned any better.
There you go. Okay, so let's see if we can get some data out of this, right? So I'm going to click on results for that time period, for that area, for that satellite. And I hope I get some, right? Here we go. So I get
Just 2 feet below sea level.
just 2, really? Is it only 2?
Yeah.
But when it floods, it can go way higher.
Yeah.
So, yeah. Anyway, that guy was predicting like 22 feet above the ground or whatever. Yeah. So anyway,
Needed result option,
What was the year?
right?
What was the year?
yes, I clicked on result. I didn't click on additional criteria, which you can dig into it. I just went right to results. Oops, I was going to do it again. Okay, so that gave me, well, 6 data sets. So I guess that makes sense. And we can click on their footprints to, nice little footprint there to see where they're covering during that time period. So there you go. So, you know, I could maybe toss out the that one and that one, right? And maybe concentrate on, and maybe even that one. Huh? Well, I'll keep those 4, I guess. And then, so yeah, let's say we want to capture those guys. Huh?
So the mine's black. The result is black.
Really?
It has a circle with a red, like, no, you may not. I wonder if I don't have mine.
Well, let me see.
Did you put your
So yeah, to get this data, yeah, you gotta log in here. So I do have an account. So let's see if it's gonna let me. What? Okay. Oh yeah, my password wasn't updated. That's weird. Okay. Once I'm logged in, now I have the ability or the option, it's not grayed out, to download the data. So I believe if I just pick one of these, so which one do I want to pick? Let's get right on that one. That's pretty good. So if I download options on this, I get quite a few options, right? So we're not quite done choosing stuff, right? Yeah, these are all the TIFF. Oh, there's the product bundle, the whole shebang. Let's see, close that. Add all to bulk. And I think that's, Is that the same stuff? Now, I would have to read that. I don't think so.
Well, there's a thermal additive.
Yeah, maybe just natural color though for this particular one, right? Natural color.
The thermal would pick up the vegetation, right?
Yeah, yeah. But I was mostly interested in the water, right?
Yeah.
So we'll see. We'll see what it does. So that is the reflection. Yeah, let's see. Let's go back and I'll put it in my chapter 6 folder and
You're putting yours in class data.
I'm going to put it in my own folder
Oh.
because, but I'll share it with the class folder too, for that matter.
Oh, okay. 'Cause
That way.
I don't think we're logged in.
Huh?
Are you logged in?
Oh, right, because you probably don't. You can sign up for an account and do that or whatever. But yeah, I'll put this on the class data folder so we can all pull it up in ArcGIS or whatever and see what we get. Okay, okay. So we downloaded it. I'm going to go ahead and grab the other one too. Yeah, that would be a good one too, probably. So I'll go ahead and do the same one as I did before. This first one, I think. Going in the same place. Okay, and it shouldn't take too long because they're pretty low res. Okay, and I'll just pull up. I'll make a copy of the New Orleans folder. Notice no spaces. And I'll put it in the class data folder in the chapter 6 folder. Okay. Yeah, we did a bunch of other ones too for that. So there's a bunch of data already there. But anyway, I'll pull that across. Okay, so let's open up ArcGIS Pro and just add those images to our list. So since it looked like there's only one, maybe two of those images for that between that time, then I would maybe go back a year, same time that year or whatever, and look at the change. There is another, and I'll show you video of the other thing, but yeah, let's just take a look at, start a new map here. And I'll put it in my New Orleans folder that I just made. Yep, just making a new map, and I'm going to just add those two images into our map here and see what we get. Should be these two, so I'll just plop them in. Oh, and do you remember what pyramids are? Right.
The satellite, the area. Is that what? No?
Well, it basically, if you want it to build the pyramids, it will take it'll take the full resolution image and cut the resolution down and then down again and down again to for your zoom level. So if I'm zoomed out like this far, then I don't need the full resolution image, right? So it'll give me the lower resolution image. It cuts out the pixels, so it just improves performance, right? But it takes up more space on your drive, so you got to remember that. I think the performance is probably good enough, so I'm gonna say no. And I may regret it, but I don't think there's that many pixels anyway, so it loads pretty fast. So I'm gonna drag the other one in there and say no also. And they have a little bit of overlap there. There we go. Is that the storm itself?
Yeah.
Oh, nice. Notice you're getting a little spaces between so you're getting a mosaic basically of the passes, right?
Yeah.
So the satellite went around in strips, basically. It follows this path, takes pictures, and then they blend the other pictures with it, and that's what you get for, I wonder how many times a day it,
That's what I was just gonna ask.
Yeah.
How many passes is it making?
and I do think you can look that information up in those, well, I don't know, actually. So if I went back to data sets here and clicked on that,
Oh, okay.
16-day repeat cycle.
And what does it take 16 days?
Does it? Oh, well, 16 days to cover the whole Earth,
Yeah.
and then repeat back to where. So if it started in New Orleans, let's say, 16 days later, it would be
Started
back at
in
New
New Orleans,
Orleans. Yeah.
So we missed the whole storm.
Well, I don't think it missed it, actually, because it did pass over it. We can see that it hit it, that it saw it. Yeah. And then it passed around and it got some more of it, right? And it tiled those images up as we see. So that's an interesting little thing. So I guess that's the storm.
So actually, then the satellite circles what, so many latitudes a day before it goes out.
Yeah, if you look at the strips of,
That's only,
so it's traveling along these lines, if you will, and then it goes around the Earth and it comes back and hits again, comes back and hits again. So I wonder why that's not shifted more.
there's quite a few in one day then.
Yeah.
Yes, that's true.
And the strips stop in there, which means maybe they enhanced it, or maybe, I don't know. Interesting enough. So we can tile these images together. We can see that there's a bit of a overlap. Yes, class data, chapter 6. Alright. So I guess what I'd really be interested in is before the storm and after the storm, not during the storm. Come to think of it, right? So that might be something you want to do. But anyway, that's the idea here. And we can blend these two images together. Did we do that with the elevation data? Do you remember doing that? Kind of mix, putting, okay, we should do that then. But yeah, let's actually do that next. And then we'll watch the video. We'll take a break and watch the video.
Okay, so what is the name of the file? The US?
There's a New Orleans folder, and that has,
Oh.
so just copy that whole folder.
Okay, that's
And
what I'm
then we
looking
can put it in our, under our name.
Yeah.
for, but I don't see that.
Are you in the class data folder?
I'm looking at it.
Good.
Class, what was
Now we'd like to use a tool. So let's look at our toolbox here. I don't want to insert toolbox. I want to go to Analysis and Tools. And let's just look at toolboxes here.
Did you say yes, we want to build pyramids?
No, I said no.
Oh, you did?
Well, it doesn't matter. I mean, if you said yes, it's not gonna, you won't notice. Well, you'll probably be able to zoom faster than I do, but
Oh.
I don't know.
But it's taken a really long time to add. Is that right?
It shouldn't take too long, but yeah.
It almost seems like it's stuck.
Oh, it might be. It might be.
So should I cancel?
No. Oh, it's gonna take a while to do the pyramids.
Oh, it's
So that's
taking
probably what it's
longer.
doing.
You said
Yeah.
that. Oh, uh-oh.
No, it's yeah. Like, you won't notice, right? After that. So I forgot that it might take a while. So, and, you know, while we're waiting, let's look at the properties of this thing anyway. I think it's fairly interesting, right? So, yeah, if you look at source and raster information, it'll tell you how many columns and rows, right? So how many cells or pixels you want. So there's 7,000 by 7,000. So what is that? 49 million. So that's like a 49 megapixel image-ish. Number of bands, so it has red, green, and blue, right? So the bands. So a different kind of image, like infrared or something like that, or a multispectral satellite image would, well, it could be at a TIFF format too, but it could have it could have like 7 bands, and they're not just visible colors, they're infrared and some other wavelengths, maybe a narrower band of wavelength for a specific, like vegetation or something like that.
So how do you tell it's a red, green, and blue?
Well, I kind of peeked. So, well, see on the, see your table of contents?
Oh, gotcha.
Yeah, I looked over there.
Oh.
Sorry, I should have mentioned it. And I'm just joking too.
Tell us what you're
Okay, so I want to join these together, right? So I'm going to go to my toolbox, right? And I'm going to go to Data Management Tools. And I'm going to go to Raster. And then there's some mosaicing tools here. Yeah. So what a mosaic is, I mean, there's a lot in here. I got to find what I'm looking for. But what I want to do is create I don't really want to make a mosaic, but a mosaic is a compilation of more than one raster, right? More than one file, if you want to call it that. And it's nice because a mosaic isn't just some super large image, right? Because you can put like 100 images, a 10 by 10 grid of images, and that's a mosaic, right? And so you can change out those images, like maybe put in a new satellite image or something like that if it was too cloudy that day or something. And so you have all kinds of options with the mosaic. In our case, we only have 2, and maybe we want to change out the images for like previous ones and after ones or something like that, or maybe we just want to merge these together, right? So you can do all of that in here, and so that's why there's tons of tools in here. I'm trying to find which one I want. So we can add rasters to a mosaic data set. We can do a bunch of other stuff. What am I looking for?
So if I cancel this, can I check the
You might as well just let it go.
Oh, okay.
Well, actually, yeah, you can cancel it. Yeah. Okay. Yeah, probably a good idea to do it. So with these two, I just want to create a mosaic, I guess, and this allows me, and I just hovered over it, and you can read the little description. It merges, and I think that is what I want to do. Merge these multiple existing raster data sets or mosaic data sets. You can merge mosaics as well with this. And so I'm going to go ahead and click on it. And the input rasters, I'm just going to go ahead and choose both of them. And the target raster is just, well, it's going to be put into my default geodatabase anyway, so I'll just name it. Okay, I think that's all I have to do, right? Oh, it must already exist, right? So I forgot. I have to create like an empty raster data set to join those together, or I think I can mosaic to new raster, which means I don't have to have an existing one. Yeah, that's the one I want. So I'll do the same thing with this, with the mosaic to new raster. That way I don't have to create a blank one or whatever. I'll just make one right from the start. So the output location, that's going to be my geodatabase. I can put it in a geodatabase, I think, or I'll just keep it outside in my folder. No, I can't.
What's the raster under?
Data management tools. Data management tools. Potato. The name, I'll just call it NO for New Orleans, or Katrina, since it's spatial reference. I don't even know what that is. Yeah, so it's a WGS. It's a UTM zone 16 north. That's the native coordinate. Well, not native really. That's the projected coordinate system of the images. So, and I'll leave the bit depth because that's going to be the same as the originals. So that's good. The cell size, if I leave it blank, it'll just be the cell size of the originals. So that's nice. Number of bands, I think I can leave that oh, that is required. Is this required? No, that's optional. So number of bands, 3, right? Because that's what the other two have. So, and the interesting part now, not that all that wasn't interesting, but that's good.
The only thing is New Orleans to the left of our map.
Oh, look at that.
And I never.
I thought I had picked the, I must have picked the wrong one.
Pick the other two.
Well, we got Katrina in it. Well,
You know what? I don't know, but I thought you picked the right ones also.
yeah, well, sorta. Anybody want
No,
to?
I did
Yeah.
Yeah.
Okay, good. What's it measured in? Usually.
What's it?
Oh, it's the oh, what do you call it?
Well, I didn't hear the question, sorry. What's it?
Yeah, how big are the cells of these images, in other words?
Oh, doesn't it say on the scale?
Well, remember when we went to the properties here and we went to source and raster information?
Oh.
I didn't really pick up on that, but it should say in here.
Source.
Yeah, look at that. Cell size, X and Y directions, but they're usually the same.
30 feet per meter.
Yeah, that's a good question. Is it feet or meters, right?
Yeah.
Well, the coordinate system's Universal Transverse Mercator, or the UTM, right? Which is meters natively. Although it doesn't have to be. It could always be converted. It should tell you in here somewhere. Yeah, see, all these measures are in meters. And then you look at the map itself, that kind of clues you in too, because when you added the data to the map, it changed the coordinate system to that of the image that you added.
So it's 90 feet by 90 feet.
Yeah, pretty much, right? Yeah.
How'd you get, oh, you just, gotcha.
Yeah. And yeah, under spatial reference, finally, you can get to linear unit meters. So there you go, after all that. Good. So cell size, I could type in 30 here, but if I don't type anything, it'll be 30 anyway. So,
Yeah.
okay. Then the interesting part here also is the operator. What's it going to do when you have overlapping cells, right? Is it going to take the first one, the last one?
Combine them.
Yeah, we can do some sort of combining. First, last, blend.
Blend.
Mean takes the values and averages them. Maybe that's better than blend. I'm not even sure what the difference is. It may just pick a color that will blend well to the next ones, which I think is less useful than mean. But anyway, color map, I don't think we need that. Yeah, we don't need it.
So did you do blend or mean? I can't see the word.
I did mean. Oh, here are the explanations. Blend, the output cell value of the overlapping areas will be a horizontally weighted calculation of the values of the cells in the overlapping area. The mean is the output cell value of the overlapping cells will be the average value of the overlapping cells. So it still may give you a shifted color where it doesn't blend nicely, but this thing is, see, in fact, if I zoom in on this, see how the southern picture, it's been enhanced a little bit differently than the one above it. So we have a more cyan colored kind of clouds, I guess, or hurricane. And the one above it is less stark. So if I blend just the cells that overlap, and another way you can look at that overlap is, I could do a swipe and see how it overlaps it. It overlaps quite a bit, actually, up to here, huh?
I like the other color.
So if I swipe those, yeah, they're kind of,
You lose the definition of the cloud.
yeah. Yeah, there's quite a bit of blend there, huh? So if we do like a blend, I think maybe a blend would work better, huh?
Turn on the blender.
Let's blend it up. Okay, and yeah, good enough. Let's run it. So what this does, right, it creates one raster out of those two, basically. Yeah, we don't need that. We don't have a color map. This is like a natural color kind of thing, so it just has. So you're missing something? So you're missing a parameter. So here's a good question. Like if we build the pyramids and we don't want them, oh, that did work. I guess I must have accidentally. So let me take these out. I do not know. Yeah, that's interesting.
It totally changed position on the map, didn't it?
Oh, okay. So it just has, it's culling what I see. So it's okay. If I zoom out too far, it's too many pixels. So it's kind of killing it for me. Let's see.
That's because you said
I don't know. Can I display? No. Huh. Yeah, I'm not sure what I would do with that. Anyway, I wanted to look at where it's blended together, like where this one meets. So if I zoom in on this area, so it is blended. You can kind of see it's a little more what do you call it, vibrant cyan than the northern part of it, but looks okay, I suppose. Yeah.
Why do you have the space in between?
Well, yeah, those are the as the satellite strips, the paths of the satellite.
How cool.
Yeah. Yes. Yeah.
It's telling me how many grids and things in there are.
Yeah, if we go to the property. So the question was, if you have something, if you have the pyramids built, under the raster information, you can tell if the pyramids are built here. It did build the pyramids. Can we unbuild the pyramids, right? So right here, it automatically built the pyramids for me. Thank you very much. And that's why I'm probably losing a lot of those.
That you pressed no on that twice.
Yeah, but this was the, yeah, I wonder if under environments, it was building them anyway. I may have missed that. Yeah, right there, build. I could have unchecked it.
Oh,
Okay, so the question is, so so now I have an example to use to answer Michelle's question where, can I unbuild the pyramids? And I think you can, and
Yeah, just uncheck that box.
rerun it. Yeah. Well, that is, yeah, that's the tool we used, and it built the pyramids for you because of that. It would have been a lot faster had you not, had I not. Anyhow, had you guys not left that checked, you could have been done a lot faster. Anyway. So if I go to the same location as this new image, right? So if I right click and, oh, it's in my geodatabase, isn't it? There it is.
What is my skills?
I wonder if I can unbuild here. Probably not. No. Well, I'm just kind of poking around, see if I could find the in the properties. Same thing. Yeah. Oh, that's actually, where am I? I'm not even looking at the right thing. Yeah, I was in the wrong area, sorry. So again, in here, I can't change that.
But you had it there. You could uncheck it.
Well, and I could have rerun the tool and rebuilt another raster
Oh.
without the pyramids. But the question really is, how do you unbuild the pyramids, right?
Got it.
So aside from rerunning it, I think,
You did undo up there.
yeah, an undo and then redo it. For some reason, I thought you could. Yeah, I don't think you can when it's in a geodatabase either. Take a quick peek. Yeah. Not going to be able to look through. I thought I might be able to, but this is what the geodatabase looks like in Windows. And I was looking for maybe a table or a bunch of tables with different raster resolutions in them. But
Under in the toolbox under raster properties, there's a build pyramids.
yeah, is there an unbuild pyramid?
I know.
If it was just a TIFF image like this one, I think you could go back to Windows and just delete the other ones. You can just see them and delete them. But when it's in a geodatabase, I wonder. Yeah, I just don't think you can.
Conversion tools.
No, close.
That's from that.
Yeah, there's not much you can do. Yeah, I don't think you can.
If
Sorry.
you have the permit, I mean, if you also have the permit, why do I have the black?
Well, because yeah, just one more thing here. This is a mosaic, right? So if I go to its properties, it looks a little different, right? So tells me how many cells and things in it. I could add, I think, because this is two images put together, I could add more rasters to it if I wanted to widen the area or something like that. So that's nice. Yeah. Good. Okay. So let's look at